Yo, what's good, guys? Today I'm going to talk about the second derivative of e to the power 3x times sine 2x. Well, why do I say it is tricky? Because you have to do a lot of product rules right here. So, here's the deal. Let's observe the equation. We've got one component here and a second component here. So the very first instinct your brain needs to come up with is to use product rule. So what is product rule? Let's define and like this one, okay? Let's define an equation like this. So what's the product rule about is when we find the derivative of f of x, then we first find the derivative of x and then copy y and then plus x and then find the derivative of y. That's it. This is the product rule. So next we're going to find the first derivative of e to the power 3x times sine 2x, which is a pretty easy task, right? Okay, I'm gonna use, is it blue? I want to use blue. Okay, so let's find the derivative of e to the power 3x times sine 2x. Okay, now, so for the first component, we're gonna find the derivative of the first component. So what's the derivative of the first component? Of course, it's gonna be, right? You need to subtract. Wait, this 3 to 3, right? You need to find the derivative of the power too. Yeah. So let's move on. And then times sine 2x plus, we copy the first component, e to the power 3x, and then times cosine 2x, and then we need to times 2 because we have 2x in here. Oh I'm sorry. Yep, 2x, we times 2, right? Okay, now let's find the first derivative of this equation. Let's simplify. Yep, pretty clean, right? It's clear and it's good. So we have to further simplify it. Yes, if you don't want to use two product rules at the same time when you're going to find the second derivative of this equation, and I guess I highly recommend you using simplifying this equation. So let's simplify. It's an easy task, isn't it? Yep. And then plus 2 cosine 2x. Done. And what about the second derivative? So we're gonna find the derivative of this thing again. And then we we can copy the first component again. Yeah, it's the same way. Okay, we can copy. Okay, we copy. And then we find the derivative of this thing. Okay? So, first, it is changed to cosine 2x. And then we times 2 here. It implies 2 times negative sine 2x. And then times 2. Because, like, we actually need to remember finding the derivative of the things inside this, like sine, cosine, tangent, cotangent, secant, cosecant. I've seen a lot of people forgetting about finding the derivative of, like, the inside component of the like sine, cosine, and tangent. Okay. Then plus, okay, we're not gonna have enough space. Why's this note so freaking small? Okay, and then we find the derivative of e to the number 3x, e to the power of 3x. Oh my god, my tongue hurts. Yep. And times 3. And then times, I'm just gonna crop this thing because we're gonna copy it. Copy. And then paste. Yep, exactly. So, oh, we got a little space here. Okay, times this thing. So, it's a mess, isn't it? But you'll see something very interesting after it. Okay, let's simplify, shouldn't we? Okay, e to the power 3x times 6 cosine 2x minus 4 sine 2x, right? And then plus e to the power 3x times 9 sine 2x plus 6 cosine 2x, right? And then we can actually combine these two things. Isn't it amazing? Right. So, cosine 2x, 6 cosine 2x. Let's highlight it, shall we? Same component. And then same component. Good. 12 cosine 2x. Good. So, this is the answer.